Okay, so next we'll be looking at a quick run into the R. I'll be covering the few basic data types that we have, operators, vectors, how you construct vectors, assigning names. Um, so like in Python, you have the arrays usually start indexing at 0, but in R, they start indexing at 1. So if you're looking at the 7th element, in Python, it would be at array index 6, but in R, it would be at 7. So just remember that you know that the arrays or the vectors in R start indexing at 1. I'll be looking at some matrix operations, list, and data frame operations. Let's start. I have my R right here. Let me show you how I start R. I just type R. I mean, this is what I get. Something to look at. If I want to quit R, there is a queue parentheses, the queue method. I can also look for help. If I want something, if I have a question, what does a particular function do? I just get the whole documentation for that, right? And if I have this help thing, the whole help document, I can just get out by queue. I mean, this is basic shell commands. So you type, when you write question mark and a function name, you get the whole documentation. To get out of that document, you press Q. All right, let's get started. The first thing is that hash is used to write a single line comment. So hi. So it does nothing. I mean, it's a single line comment, right? All right. How do you assign a variable? Like in other languages, you have var is equal to 10. In R, you can also write it. I mean, this is how you write it usually. Var equal to 10 is also okay. Variable name is equal to 10 is fine. But usually this is the symbol that you use. Basic operators, you have a addition operator, a subtraction operator, you have a multiplication operator, you have a division operator. Okay, whenever you talk about divisions, you'll be like, okay, divide by 0. What does it give? So let's try that. You get infinity or not a number. Any of the forms. 0 by 0 is also not a number, but let's put in 0 by infinity. So that is 0, 0 or 1 upon 0, right? Okay, so I have, I'm going to assign one more variable, that is x is 4, and a power symbol, an exponent, right? X raised to 2. All right. Next is, okay, so undefined results are in INF, variable name rules. A variable name consists of letters, numbers, and the dot or underline characters. So if I write it as j.2, 10, j.2, so it's 10, right? So this is allowed. But if I say j.v, that's allowed. Okay. What is not allowed here? Let's see. vj 10. So even that is allowed. But if I write vj dot here, that is not allowed. So a dot cannot follow a number. Sorry, a number cannot follow a dot for a variable name. I think it's not just for the start, right? So even if I have j.2v, and even this should not be allowed. Oh, this was allowed. Interesting. Okay, so if it's the first point, yeah, if it's the first letter. All right, a few mathematical functions. This is the absolute value, as we all know. So let's keep on typing in your R instances as we talk about this, so that muscle memory. All right. So absolute value 3 minus 13 should give me 10. That's the absolute value. Square root of 64 is an 8. Perfect. Okay, I'll just scroll this up. Next one is exponent. So yeah, it's working. That is 4 e raised to 4. Let's do log base. So the logarithm function is base e. So log 10 is 2.30. So let's do, oh, I made a mistake. It's log base e, and then the exponent, so it should be 1. And if I'm your log base 10, 1. All right. A mathematical constant is defined pi, that is 3.141. It's defined already. Let's look at a few trigonometric functions. Sine pi by 6 with sine 30, so that's half. Cos pi by 6, that's root 3 by 2. By 6, it should be root 3. 1 by root 3, 1 by root 3. All right. These are the trigonometric functions. Now, if you inverse trigonometric functions, a sine 1 by 2. Okay, just for this one, let's put a sine 1 by 2 divided by pi. I should be getting 1.1 by 6. Yeah, that's 1 by 6. Okay, so a cos 1 by 2 is also there, a tan 1. Right? So that should be pi by 4. All right, so that's inverse trigonometric functions. You have something called round. So that, so here I just put in like the decimals that I wanted to have to round it to. So that's 3.14. I can round it to 10 digits as well. So that's, oh, okay. So here's the thing. When I put the variable pi, that is defined, it is just till 6 decimal points. So if I put in a precision more than that, it's just going to stay as it is. Right? Let's just do this as 4. Yeah. All right. Next one is floor and ceiling. Now this is something I think I covered during ECS 20. So this is, if I put in 2.6, 2.7, the floor would be the integer that is lower than that. So that should be 2. If I put in floor minus 2.7, so there should be a lower integer. So that should be minus 3. Now ceiling, it's not seal, it's ceiling. So just make sure I keep on making that mistake sometimes. Ceiling would be the integer above it, so 3.6, so that is 4. 1 should be minus 4, that goes above. Okay, one more function is, so all these variables that I put in, right, I can always call them back using just the function ls. So I can look at all the variables that have been defined in the space right now. Right, and yeah, all the variable names just come out. Okay, next one is data types. So R has basically 6 atomic data types. A character, characters can be of any length, unlike in C that we see that it should be like like size 1. Right, yeah, size 1. Numeric would be any decimal value. Integer is again all the integers they do not have any decimal points. And you had to write it as 5L, and L dells R to store it as an integer. Another data type is logical, or what we call as Boolean, so logical and Boolean. And then complex numbers, that is 1 plus 6i. Anything of the form I would be considered as a complex number. Right? Let's write a few commands for that. So I'm going to say, is it? No. Right. So we defined the character char. Now we'll define an integer minus 5l. And if I print var in, it just gives off as minus 5, but it's saved as an integer. All right. A few functions that you can make use of. Oh, it's length. Yep. So the length of this integer variable is 1. Let's do it for the character variable. That's also one. That's interesting. Okay. The type of function defines the type of the variable that we have. So that's an integer. R is type sensitive, so just make sure you know that. Type of char is character. Feel free to pause this video and just try out a few more questions, a few more functions right here. The class, type of, length, dimension, and attributes. All right. Let's store a numeric value now. So that will be minus 33. All right, and one more function. Okay, let's just check the class of this. Here's the numeric, perfect. Now let's use one more function, that is an as integer. As integer 5, and let's just check the type of. Is it an integer? Yeah, I shouldn't have just put an integer. I didn't put a decimal value. Right, and let's print. So see, I mean, the stored as an integer. Next thing, oh, I think I missed a slide. Yeah, right there. This is something that you should be aware of, like to install packages. This is what you use. Let me see if this works here. I mean, I usually do it in RStudio, but I haven't tried it yet. Oh, so this happens. You just press the enter key by mistake. So just looking for one. You have to select a seed and mirror for this session. All of this is taken care of in RStudio, so don't try to install libraries here. How do I get up to this? Okay, so my laptop just hanged when I did that. So understand what you're doing before you do it. Always do it in RStudio instead of this because the GUI really helps you. Usually what is supposed to happen is that a CRAN mirror would pop up, but for some reason it's not popping up on my terminal. So yeah, don't install a library on RStudio. Install a library in RStudio rather than this. I'll show you how to do that on RStudio. All right, let's look at logical operators greater than, less than. So this is greater than, this is greater than, equal to, less than, less than, equal to. Let's write a few codes commands for that. Let's say x is equal to 4 and y is equal to minus 4. And we say that x is greater than y. That's true. 4 is minus 4. X is less than y. You should get a negative. Absolute value of x. Greater than the absolute value of y. That is false because it's equal. What if I just put a single equal, right? Okay. Next one is yeah. Let me just put in the value of this. So that's a logical operator, right? I'll have false in it. This is negation of z, so that's true. Let's put in. Let's just put the w is true. So here's another thing. When you put in the value true, all have to be caps lock, or you can just put in st. If you put in true with just a t capital, it's not enough. Okay, it is case sensitive. Now I have w to be true and y to be true as well. y is equal to negation of y. So y is false, right? Now let's do a few logical operators. Y, w and y is false, true and false is false, true, all false is true again, right? So, and or right there. Okay, next thing up is a string. So let me just put in first, oh, no space, second, please put in your name instead of my name when you're writing code. So the function that we're going to use here is paste. So that's more like a concatenation function. You see a space was added here. What if I don't want a space here? So you just put in paste 0. That should be without the space. Pretty simple. All right, next one is toOpper. I mean, this is one of the most common functions for strings, for string manipulation. ToOpper, everything goes, is all letters convert to uppercase. And I put into lower. No, I didn't save it. So let me keep going. Yay. Yay. Okay. Next one is list or arrays. Okay, so the next thing is array. So this is how you write an array. All right. So I just called a function. I'm just going to write it again so I can talk about it. Right. Okay, so the function is called a concatenation function, where you just like combine all the values of 1, 2, 3, 4 as an array, right? Let's see if we can index it. I don't know, I'm not sure. Yeah. So first one is 1. It's the value 4, right? So you define an array here, and you can index through it using the index number. All right. So let's just write another function, something else. There is something called factors. I'm just gonna write. So the factors are, I think, here. So factors are basically, sorry. Oh, yeah. So factors are basically, arrays which can be used as categories. So it can either be numeric data or like character data. Like you can use it to, like categorize things. And we'll be using that in the future, not for this course, not during any simulations, but it's just something that's good to know this, right? So let's say rainy, sunny, windy. Right, so 3 options. I mean, you just use it for categories. It's only for numeric and character data. I can change into a string. Okay. Next one is additions for arrays. This is where it kind of gets a little interesting. This is the first one, the first array that I want to have. Right, so I've defined the two arrays on the vectors. Let me just call them vectors for now. So I can just add them. I'll get, so 10 plus 20, 30 plus 60, 50, 40, 70, 80, and 90, 90. Right? I can subtract that and have the same thing, like it's an element-wise subtraction in the array, in the vector. I can multiply them actually. And that's 10, like, so it's again element-wise multiplication that happens. Now if I define a function, define another vector that is smaller than one of them, in size. So the length of this vector is 4, the length of this vector is 5. So what happens then? So if I just add them, what happens is it displays, so if this is vector v and this is vector j, keeps on adding. So it just like cyclically goes back. So if I say u plus j, it's a multiple of shorter object length. So it's fine. So you do get a warning message. But then as you see here, when I added u plus j, I got 10 plus 1, 30 plus 2, 50 plus 3, 70 plus 4, and the 1 initially came back to add to 90. So that's 91. Okay, so that is that. Let's create yeah. So yeah, let's create another vector using a replication function. So that's 4, 10. And so I have 4 10 times here, right there. Another thing that is interesting is if I put in 1, minus 1, 10. So what happens is the one, so keep on multiplying with pairs. So the first one will be 4 times 1, the second will be 4 times minus 1. So multiply the first one by 1, the second one is minus 1, again 1, minus 1, 1, minus 1. So let's see what the output is, right? Let's do it with 3 elements. No, let's do 4 actually. So here you got 4 minus 4, 8, minus 8, minus 4, minus 4, right? So it does all make sense. It does make sense that 1 is multiplied with the first element, minus 1 with the second, 2 with the third, and minus 2 with the fourth. Next is again indexing. So we just had, like, if I was the second element, should be minus 4. What if I put a negative value? I should put the last element. Everything other than the last. Oh, what happened here? Yeah, so the first one doesn't come out. The other things come out from here. So I just sliced it up. Let's do minus 3. Okay. Next. If I put in, so when I put in n2 to 4, I got the values from 2, that's minus 4, 8, and minus 8. So the second, third, and fourth values come out when I put in n2 to 2 to 4. If I had put in, right, so when I just put in 2, 4, I'll just be getting minus 4 and minus 8. So that's the second element and the fourth element, not the range between the second and the fourth element. Next one is defining an array, defining a matrix, sorry. So the matrix definition is pretty cool. You have to write a lot of things here, so let's just write it down. First, the data 243157. Here I'm supposed to define the number of rows I want. So I'm just going to put in 2. Number of columns I want, and if I want to do it by row. That's the error I was talking about, guys. Let me see if I just copy it. I'm just gonna type it again. That's why we don't really work on the terminal. I think I'm making a mistake. I'm missing out on a command, but if you know it, just let me know. That would be really helpful to me. I'm gonna put in fixed values. Make sure you don't miss out on the comma. All right, finally, I was able to write it down. When I put in M, I'll get 1, 2, 3, 4, 5, 6. It was by row. So it started with the row major form, 1, 2, 3, and then 4, 5, 6. Let's do a transpose of this. That was the trace, and this was the transpose. Again, what is N? Let's see. Oh, right. Because I had already defined a variable with the smaller case n, it went on to transpose that element. That's interesting. Okay, so we did the transpose of the matrix from 1 to 3, 4, 5, 6. We got it in the column major form. So that's a transform. Something to note here, something very similar to what we're doing with the vectors. So I would get 1, 3 would give me 1, 3. So that's this element right there. Let's try to see another one, 2, 2. 5, perfect. Now I want to print the whole row, the row. I'll get the second row. The same thing for the column. I'll just do comma 3. Interesting function to look at. All the functions right there. All right, so the next one is cbind. So it binds it horizontally, and I'll show the other one, lbind. Lbind it. Let's see what this is. Yeah, so I made a small error. It was not lbind, it is rbind. So when I put rbind, just add 2 more columns, that is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6 again. If I want to find the number of rows, so here's where you use the dimensional function. Let me try dimensional first. So what do I get as a dimensional value? So it's 2 cross 3. What is the dimension of the transpose 10? That is 3 cross 2. Perfect, that's what we want. So number of rows would be the first element here. So this is our vector. So if I get the first element of the vector, that's the number of rows, the number of columns, sorry. Right, and if I want to find the number of rows in another way, this is how I do it. Number n row, n equals 8.3. Perfect. Now, the most interesting one. I can actually solve the inverse of a matrix using solve. This, I mean, you need the matrix to be square, and you can actually find the inverse of it by one function. All right. Next thing is, let's do a row means. The row means will give me So it's supposed to be roaming. This is embarrassing. Okay, this is why I don't like when languages are type sensitive. Perfect, so it's row means. And the same thing is for row sums. So I got the sum, the row mean of the first, let me just put the function of the matrix again. So I got the row means, so that was the mean of 1, 2, 3, and the mean of 4, 5, 6. I also got the row sum of the first three, so that's 1 to 3 is 6, and the sum of 4, 5, 6 is 15. And I can also get call means, that is by column, and call sum. Okay. Right. So that's majorly about matrices. Next, we'll be going to a data frame. Okay, so the data frame. I'm not gonna write the whole thing down, but you can if you want to. Let me just pause the video and write it down. So it has to be data dot frame and not data frame. This right here. So this is why I don't really like to code in. Uh, oh, I'm gonna use other names here. So this be John and Molly. Those people who are trying to match with me, I'm sorry for this error. You would have made the data.frame error because of me. I apologize for that. No, I'm not adding in the world. And age is 45. Holiday. I'll just make it really quick now. Okay. We're good to go. Yeah, hang on. Right. So when I call data, I get name as the first column, job, and the age. Right. I can put in play last data. It's a data frame. You can have the whole data frame as a string. Right. The name is John and Molly. Job is banker and police. Age is 45 and 32. If I put in summary, so here's the interesting thing. The age, because it's a numerical value, will have a minimum of first quartile. So that's 25 percentage in the percentile range, median, mean, third quantile, and the maximum range of that. It's interesting just for two values we have the statistics, but anyway, yeah. All right, so using summary, you can get that. I can call a particular column of this. If I just put in data dollar age, I have the two values in that column. If I put data dollar job, I have banker or police. What else? I can actually create another data frame using same data frame by data dollar name data dollar age. You can have a new data frame with just the two columns that you wanted. All right, next up is see the functions, but let's just start with the already defined functions. The first one is, so when I say sequential 1 to 500, it essentially just, adds all the numbers 1 to 500 in an array or in a list. Now, a few functions for that: maximum value, minimum value, mean value, the sum. Yeah, so basically these are the functions that are defined, the sum of them. Next one, let's write our own function. That's my name, the function name is a function, arguments, and I just print that in the function itself. So now I'll call my.function n, 1, and 2. So I should get an 8, right? Perfect. So I call this function from my.function 10, 1, 2. So this is how you define a function, just like you wrote the array. The function name is equal to function. The function is a keyword here, the arguments, and write the function down right there. Okay. Next up is, oh yeah, we can also call it you having like writing the names itself. So I just put in another func1 function is equal to 10. So I think this is like default values. Okay, let me type the function again. Right, so let's call the function my.func1, putting 9, 4, 3, and 3. I should be getting 6, or like 9 minus 6 is 3. If I just put in my func1, put in my func1 8, it goes as 8 minus 5 minus 5, that is minus 2. Perfect. What else? Yep, so what happened here was that I just put in one argument and it took the other two as by default, right? So what else? Oh yeah, let's do an if-else statement. So if-else are pretty simple in R. So just as any normal thing, if x is equal to So print j, print. Oh, okay, you wrote the Python so it's print parentheses. So if I said if x equal to 4, then j. Why didn't just put print x as something else? It's already 4, right? You know that. Um, it's not equal to 4, it's actually equal to 3. All right, so here's something interesting in R. When we talk about data functions, so so there are a few data sets that are already in R that you can use, like a lot of them. So this is quite a good amount. So I can like get a particular data set, Nile. Let's store it as something. So I can like import it into the file. So I can just put date, like the data set is right there. To print something, let me just put Nile and the first two. So I print the first two values in there. Yeah. In the first 20 elements, the head is used for that. I can do a question mark Nile. It gives me the whole thing, like the whole description and the documentation, right? So it's a time series of length 100 and measurements of the annual flow of the river at Aswan. Um, let's do number of flows from Nile. Interesting, I'm getting null for that. Let's plot a histogram. Yeah, that's pretty cool, right? I mean, you can just get. This is interesting. I just plot it. Let's do a plot of the density function. So the density function is basically a smoothened histogram. I'll just plot the histogram now. So you can see that, right? All right, let's do a box plot. So you get the quartiles and the mean and the standard deviations. Okay, next up is, again, using the sequential function from -2 pi to, so from is equal to -2 pi, and 2 is equal to 2 times pi, and the length of output 100. Yeah, I don't see the error here. From is equal to -2 pi. Oh, right, so you have the whole value from -2 pi to 2 pi. And let's say y is equal to 2 times sine of x. So you have the value from somewhere from very like negligible. It's -2 pi, so that should be 0. So it's tending to 0 right there. Okay. So let's plot these values. Something to note for simulations that you will be doing. So that's the plot of the whole thing. So that's a sine curve. Um, that's 9. right. All right, something to note about simulations is that a lot of times you will have to plot, and R has a lot of pretty visualizations which you should really take, like, use to your advantage. Um, all right, next up is using the sampling. So yeah, we used all of that. So yeah, sampling in R. Sometimes you will want, okay, let me pause this video right here because this is the part of the second section.